NATS supports a lot of different mechanisms for authentication and authorization, from a simple username and password in a config file to full-blown decentralized auth with zero trust constructs. But what if you need something beyond these options, or you really need to integrate your NATS user permissions with another system like Active Directory or even OpenID Connect? This is where a fairly recent feature, Auth Callout, can come in clutch. In this episode, I'll cover everything you need to know on the NATS Auth Callout feature, and we'll even turn a simple NATS chat application into a secure chat application using Auth Callout and Google Single Sign-On. So, let's get into it. But before we do, if you are new to this channel or you're just really interested in this content, be sure to leave a like and subscribe, and also just jump in, participate in the comments. Let us know what kind of content you'd like to see in the future. We love to produce this content, and getting more validation that this is interesting to you is certainly going to help us plan more content in the future. So with that out of the way, let's get into the episode. Now, this episode has been a pretty highly requested one, mainly because this feature came out maybe about a year ago, but folks have just not really figured out how to quite utilize it. Some people definitely have, but I think we need better documentation. And so this video is kind of an attempt to give you a really neat example of how you could use something like Auth Callout to power your NATS-based services. And so let's go over some of the architecture of like how auth works inside of NATS, and then we'll jump into how Auth Callout, really makes this a super powerful mechanism for integrating auth into your NATS application. So first off, how basically does auth work in NATS? Well, there's a lot of things that go on with it, but I'm just going to kind of simplify it for a bit. You have a client and then you have a server, right? And the client needs to be able to connect to the server. And so it makes a connect request, and it's going to supply, something to that server to be able to authenticate with. This could be, a JWT. It could be just a plain old token, a username and password, an N key, but it's going to pass something in there. And the server is going to use the knowledge that it has to be able to authenticate that user and then send back permissions or authorizations that the user is able to do. And once that client is connected, then it can start sending NATS messages around. So what kind of happens in the background is when the server authenticates a user, it creates a connection ID or a CID for that client. It then binds that client to a particular account if you're using multi-tenancy. If you're not using multi-tenancy, it's just going to be the $G account, which is the global account. And that's going to assign things like permissions and limits to that user. And the way that this generally works is you can either put your users defined inside of a NATS server config, which is like the easiest approach, but isn't super scalable, or you can go our decentralized JWT route, which is a bit more complex and kind of hard to handle, but it gives you the most power because you're able to scale this pretty far. You don't have to update any server configs. No secrets live inside the config file. So there's a lot of benefits to using this, but it can be a little bit cumbersome to use because of its decentralized nature. And so this is where something like Auth Callout comes in, which is a third option that you could use for your authentication. And you could actually mix it with a lot of other Auth and Auth constructs here. But the way that the Auth Callout feature works is the client is going to do the same thing. It's going to connect via the server. It's going to send a connect signal with any sort of information, whether it's a token, a JOT, username and password. And the server, instead of with its knowledge trying to authenticate the user, it's actually going to delegate that to an auth service that you create and maintain. And this auth service is just like any other NATS request reply service. In fact, in our example today, we're going to go over exactly how to write one. But what ends up happening is the server is going to pass info about the client. It's going to pass an N key that it generates. This is going to be the user's temporary identity while it maintains connection to the server. It's also going to pass in its own server ID for more security's sake, no spoofing or anything like that. That's going to pass in connection options as well. So it's going to pass in literally anything the client passed, from its cert information if you're using MTLS to any sort of token or JOT or username and password that was sent. And you could use all sorts of different available options for you to kind of define the context in which you want your auth service to handle this. And what the auth service does is it goes and looks at whatever was handed, and then it decides for itself, what type of user permission permissions and whether or not that user is authenticated to actually participate in the system. It's going to result in a signed user JWT, which is the same as our decentralized auth. It's using all the same tool set, except that you don't have to mint that JWT and hand it to another client, and every time it gets updated you have to keep handing it to the client and having them restart their process or anything like that. This just all happens kind of transparently and automatically, and so things like dynamic permissions, being able to mint permissions on the fly, things like that. Auth Callout is just a perfect solution for this. The other thing I want to say about this is the auth callout mechanism is end-to-end encrypted, or you actually have the option to do that. And we do that with an encryption key called an X key. And we won't be going over that today because that kind of introduces a little bit more complexity. But you can actually have an extra layer of security by making sure you automatically encrypt all the payloads that go back and forth between the client or the server and the auth service. Okay, so why is something like this cool? Well, when you think about it, if you have an auth service that the server will call out to, you can pretty much plug in any auth system you want into NATS, whether that's Active Directory or OAuth or OpenID Connect or really anything, your own database that you want to use for that. All of that stuff can be used and utilized to create users in NATS and give them permissions. One of the other benefits to using something like this is that you get easy access to your key value stores, your object stores, basically anything that's in NATS, because the auth callout service is basically a connection into the NATS ecosystem. And so you can imagine all the kind of composability you have where you might not even need to have your own database. You could have a database powered by KV that has all of your user permissions in it. And so today we're actually going to be taking advantage of this by using a combination of OpenID Connect and Key Value Store to have both a profile and an authentication and authorization scheme. You can support mixed mode auth with all the other different types, whether you want some users defined in the config plus auth callout, or you want to do the decentralized auth plus auth callout. There are options for you to be able to kind of mix and match some of those. You get to, like I said before, generate permissions on demand, which is great because as soon as the client connects, that's when you could mint those permissions, and you could do that based off any of the other information that the client has in the payload, plus any other context or information that service might have from a database, from a config, from whatever. And then you also have the ability to do end-to-end encryption with X keys, which is just an extra layer of security on top of that, so somebody with heightened privileges can't just snoop and inspect those payloads at will. So let's kind of look at this example. And before I kind of get into this this chart, which looks a little bit complex, let me talk to you about kind of the application that we're going to be playing with today. So I have a basic NATS chat application, and it just asks me for my email address to be able to log in. You can think of this as a Slack clone or something like that. But once I log in, you can see it pulls in my picture and my name, and all this stuff is stored in the key value store, by the way. And so I can say hello world and post inside of Slack. Now this is great because I can have multiple channels and stuff like that, and all of this is driven through a combination of NATS key value store and NATS stream. But one of the problems with this application already is that it has no sort of security, basically. I just supplied my email address, but if I want to log in again, I could just say I'm Byron at Synadia.com. And now I'm all of a sudden impersonating Byron. Hey, Jeremy. Which isn't great. Because we obviously don't want to build applications like this. And so the way this is working right now is that I have a single NATS user that just has permissions to do anything that they want, which obviously isn't great if I want to write some chat clients and distribute them to people. And so what we're going to do today is we're going to lock down these permissions, and we're going to do so using a combination of auth callout, OpenID Connect with Google, and a NATS key value store to store all of that information. And so let's kind of get started on what that example looks like. But before we do, I'm going to jump in and talk a little bit about the architecture here. So first off, what we're going to do is we're going to have the client, before they connect to the NATS server, they're going to actually reach out to accounts.google.com and go through the OAuth flow, basically that sign in with Google button that you're all used to. And that's going to give you a Google JOT that is signed by Google that we could verify on our end. And so the client's going to get that, and then it's going to try to connect to the NATS server with that JOT. Which is actually cool because it's not a NATS JOT. It's not, any sort of special thing. It's exactly what Google handed back to us. We're just going to give that to the NATS server when we connect. And what the NATS server is going to do is it's going to call out to its auth service with that Google JOT. The auth service is then going to verify that JOT, that it was signed by Google, that it's valid, and then based off of that information that's inside of the claims of that Google JOT, it's going to return a signed NATS user JOT that the NATS server can then bind to and bind that client to. And so it's really, really nice. The last thing I also will say here is the auth service not only does that for the client binding, but it will also update this workspace KV with any of the profile information that comes back from the Google JOT. So your photo, your name, your email, all of that stuff that comes back from Google, we get to utilize here. So we don't have to update any profiles or anything like that manually. And so it's a very simple architecture, but you could see if you layer on more features on top of this, you could actually build a pretty comprehensive and secure chat client with just NATS and an auth callout service, really like no other backend, which I think is really, really neat. And so that's pretty much it for the example. Let's go through and actually just write this code. So the first thing you're going to want to do before configuring an auth callout service for your NATS server is to generate a pair of N keys. And the way you do that is to use the NSC tool. You can just say NSC generate nkey -- account. And this is going to give you two keys. It's going to give you your secret key, and it's going to give you your public key, which starts with an A. Now that I have my N keys generated, I'm going to go ahead and go over to my NATS server tab, and I'm going to edit my nats.configuration file to add support for this auth callout service. Now, I already have a NATS config set up here that's configuring my WebSockets for my chat applications, configuring Jetstream, and also creating a chat account with Jetstream enabled. And you can see here that I have one user called user with the password pass. This is what I'm using inside of my chat applications right now, which is super insecure because they have access to everything in the system. And so we eventually want to do away with this, but as we're testing, we're actually just going to be using this as kind of our backdoor for the NATS CLI and things like that. But to configure something like our auth callout, we're going to create an authorization block. And inside this authorization block, we're going to be configuring the auth callout feature. And in here, there's going to be three things that we want to pass. First, we want to pass an issuer. And this issuer is going to be the public key of the N key that we just generated. So we'll go ahead and copy that. And the reason for this is we want to make sure that whoever has signed these requests, that the server actually knows it and they can verify that they're signed. So again, an added layer of security on this auth callout so we can avoid any sort of like spoofing or man-in-the-middle attacks. Secondly, we want to add an auth users field right here. And this is going to be any user that we want to kind of bypass the authorization and utilize a user that's configured here inside of accounts. And so we want one for auth. And we also want one for our backdoor called user. And so I'm just going to copy this and put an auth user here. And you're free to use username and password, but I recommend that you use something like N keys or even the decentralized JWT auth for a lot of these users, so you're not passing all of these things in config and having kind of plain text passwords stored. But for brevity's sake, we're just going to keep it as is. Lastly, we want to configure the account that we want to discover these users on, which is going to be on the chat account. And that's really all that we need for configuring auth callout in the NATS server. So let's go ahead and save that. And then we can run it. And our server is ready to run. Now, one way to test this would be to update your NATS context to make sure it's using a user that can connect to this NATS server. So I can say NATS context edit default. And you can see that I have user and password set as user pass. This is kind of my backdoor just for example's sake. But if I save this and I say NATS stream list, you can see I see my chat messages stream right here, which means I'm authenticated and everything's working out. Now that we know that we're authenticating correctly, let's jump in and write this auth callout service. Now, there's a lot of code that kind of goes into this, and if you want to see the full code example, you can go down to the link below, and you can just check out that Git repo and start playing with it. I did write a couple supporting functions for this, but for the most part, we're going to start with func main, and we're just going to walk through as much as we can to write this auth callout service. So the first thing we want to do is we want to establish a couple consts. Right here, we got our client ID, which is just going to be the client ID for my Google OpenID Connect configuration. If you want to set this up for yourself, you're going to have to go through kind of Google's OIDC setup flow inside of their developer portal, but this is kind of what you get at the end of the day. And this is also what my front-end application is using. Next, we're going to have to get our N-key seed. Now, we probably don't want to put this straight inside of our application, but for brevity's sake, we're going to do that. You likely want to inject this in via the environment or via secrets in some way, shape, or form when you're actually deploying something like this in production. But let's go ahead and grab that secret key that was generated from our N-key command a couple minutes ago. There we go. Now we can get into our main func. So first and foremost, we're just going to connect to NATS. We're going to say nats.connect. And we're going to use the NATS default URL, which is I'm running from my server. And we're going to say nats.userinfo as our authentication scheme. And we're just going to use auth and auth, which I believe we are using for our configuration right here, auth and auth. So this is going to represent our auth service. Now, once we have that, we're going to go ahead and handle this error. And we can continue on with the next part of our example. We're going to grab that key pair and make sure that we can parse it out correctly. So we'll say nkeys.fromSeed, and we'll just pass in a byte slice of our nkey seed. And if that one fails as well, we're just going to want to exit early. Okay, there's a couple more things that we want to set up before we create our actual auth service. We want to go ahead and create our Google verifier, which I have some supporting code for. We're just going to say new Google verifier, and we'll pass in context.background, and we'll also just pass in our client ID that we supplied up top. Okay, and once again, if error is nil, just leave it. Lastly, we want to establish a connection to our KV bucket that's going to represent our workspace. And I actually have this wrapped in a little struct right here. So we're just going to say workspace, and error is new workspace KV. We'll pass in our NATS connection and the bucket name, which is going to be chat workspace. And this KV is already created for me. I just need to connect to it. And that way I can start inserting user info into here when somebody authenticates. Okay, now we can create our actual auth service. I'm going to go ahead and say auth is new auth service. And this is just a little wrapper function that I created to make things a little bit easier. You can kind of look at the source code if you want. It's not too difficult to grok. But the basics here are that the NATS server is going to hand you an encoded set of authorization request claims. And what it wants you to hand back is response claims for this particular authorization request. And the meat of it is actually these JWT user claims that you're going to send back. And so we're going to create a set of user claims. We're going to add permissions or limits or whatever we want from them, but only after we verify that that this JOT that is supplied to us has come from Google, and that we know who this person is. And so let's go ahead and write this little auth handler. Now this is going to be called every time that somebody tries to authenticate. So I'm just going to put a little log message here that says we've received the request. That way we can have a little bit of debugging here. And then we're going to create a set of claims using the JWT library from NATS, and we're going to say new user claims. And the subject is actually going to be coming from our request. Remember when I mentioned that the NATS server is going to be creating a new N key for every single connection? We can actually find this by saying request.user N key. And now we have a set of claims that we can configure. And we're just going to return these claims and nil if everything's hunky-dory. Now, we can stop here and we would probably be sending, valid claims for everybody, but that's not what we want to do. We actually want to make sure we do some checks, return errors if there are any, and then mint specific permissions for that user based off of their email address. So let's go ahead and do that. First off, I need to tell NATS what account we want this to bind to, and we do that by configuring the claims audience. So I can hard code this to chat like this for this example, but you can also pull this from wherever you'd like. Now I'm going to go ahead and get the Google claims from the actual connect options that are coming from the client. So I'm going to say v.verify Google JWT to parse that out, and then we're going to pull this from the request connect options, and we're going to pull it from the token field. So our client is using the token field to pass in that Google JOT, and so we're going to parse that out, we're going to verify it, and we're going to extract some of the claims. And so if you can see the type here, it's of type Google claims, which includes things like name, email, photo, things like that. All right, let's go ahead and if there was an error here, we want to make sure we return it, and that will result in an authorization error, which is great. We just say claims error. Okay, so we're handling that error here. Let's go ahead and parse out our user ID. Because we're putting these user IDs in a key value store and it's inherently inside of a NATS subject, we don't want to use the email just as it is. But what we can do is we could base 64 encode this email so it's kind of safe enough for subjects inside of NATS. So let's go ahead and do that. I'm going to say base 64, standard encoding, and we're going to encode to string. And I'm going to use the actual gclaims email right here and wrap that in a byte slice. And so we're going to be encoding our email into user ID. And then once we're done with that, we can then start, we can then add this user to the workspace. And so we're going to take that workspace KV and we're going to add or update the user with any of the information that we got from Google. So things like their photo, their name, stuff like that. So if they update their photo or their name in Google, next time they sign in, that KV is actually going to update that profile information for our chat application. Let's go ahead and do that. I'm going to say error is workspace.addUser, and we're going to call this a workspace user struct, and we could just fill in all of these details here. So we're going to use their user ID for the user ID. We're going to use our gclaims.email for our, gclaims.name for our name, our gclaims.email for our email, and for our photo URL, I believe Google does give us a photo right here, a picture. All right, and so that should add our user to the workspace, but we do need to handle this error. So we'll go ahead and just copy and paste. So now our user is added to our key value store every time they authenticate, which is great. And now we get to do the fun part, which is, hey, what kind of permissions does this user get based off of their email address? And so since this is a chat application, we want to give them permissions to be able to view the channels, be able to kind of like look at the profile information from the, NATS KV, things like that. But where we really want to tie things down is we really only want them to be able to post on behalf of themselves and nobody else. And so what I'm going to do is I'm going to go ahead and we're going to go ahead and start updating these claims. We're going to say claims.name equals user ID. So that way NATS kind of knows that, okay, we're talking about this particular user ID. And then we're going to set some permissions. And I'm just going to paste this in. Oops. To show you kind of what a set of permissions could look like. And so in this instance, we want to allow all of these clients to be able to get info about the Jetstream API. We also want them to be able to get info about the chat messages stream. We want them to be able to create and operate consumers for the chat messages stream. And then we also want them to be able to kind of do a lot of the same things, be able to look into the workspace KV, which includes all of the user profile information. The thing that's kind of notable here in terms of what they're allowed to publish is we're going to allow them to publish to chat.star.connect user ID. And chat is kind of the channel to say this is why I want to post a chat message here. This star is going to be a channel. And so right now we're saying that any user that goes through this authentication method can post to any channel. And then this %s representing their user ID, meaning they could only post on behalf of their own user ID. And so we kind of use this as a mechanism to verify, who has posted what. And you'll see this kind of working in just a minute. But that's kind of the basic subject structure that we have. One challenge for you at the end of this video is if you want to download this and you are trying to expand this to allow users to belong to certain channels and only have those channels available, that would be kind of a fun challenge to kind of give yourself for these permissions. But you could see that there's so many things that we can configure to lock down these clients in a very dynamic way, which I think is really, really neat. So once we're done with that, we simply just return the claims, and they're automatically signed, and we're able to move on from there. So we've created our auth handler, but now we need to create our NATS service to be able to actually handle that. And so we're going to go ahead and create a NATS service using the micro framework. I'm going to say micro.add-service, and this takes a NATS connection and a micro config. Okay, and there's just a couple fields that we want here. We want to have the name. We'll just call this auth. We want to have a version, which we'll just say is 0.0.1, and we can just put a description here, something like handle authentication for Google JWTs in chat applications. Okay. And then lastly, we want to have an endpoint to handle this. And this is where we want to be obviously very careful here. When we configure an endpoint, we want to have the subject, which this is the subject that we're going to bind to listen for these requests. And it's very specific. The NATS server is going to send an sys request user auth. This is the subject that NATS is going to be using the call out for. Lastly, we want to say that our handler is auth, which is the handler that we just created up here. And then we should be good to go. Oh, that's not a pointer. Okay, so we've added our service. We need to handle if there's an error. We'll just log.fatal again. And then lastly, I'll just kind of do a log print ln. And we'll say, listening on sys.request user auth, just to kind of give us some confirmation that everything's working. And then we'll runtime.go exit, which isn't perfect. You probably want to really, do a really graceful shutdown here in production. But for now, this is totally fine. And that's it. In about 100 lines of code that we just wrote, we're able to do kind of an auth callout service where not only are we updating a key value store every time somebody logs in with Google, but we are also giving them special permissions to be able to do just what they need to do to be able to participate. And so let's go try to run this and see what happens. I'm going to say go run this project. And it says we're now listening on sys request user auth. Let's go ahead and try this out. I'm going to configure my web application to use SSO. So now we can sign in via the NATS chat. And you can see I could either sign in as Jeremy at Synadia or Jeremy my Gmail, which they have two different photos, which is convenient. I'm going to go ahead and sign in Jeremy via Gmail. And I'm going to say, hello world. Now, the cool part is that this profile information didn't exist before. It actually updated that key value store with that profile info, and all the chat applications were watching that key value store, so they also updated their profile info before I even jumped into chat. And so now I just onboarded a new user automatically using Google, SSO. And just to kind of prove to you that that this is secure, I'm going to go ahead and grab the JWT that Google gave me. And let's go into the NATS CLI and see what we can do here. So I'm going to go, let's jump into NATS CLI. I'm going to say NATS context edit default. And we're just going to update the token field with that JWT that Google just gave us. And we'll just, nil out these user and pass fields. And I should be able to say something like NATS stream list, and this should result in an authentication error. Yep, because there's something I just can't do with it. But what I can do is I could say NATS sub stream chat messages. So I should be allowed to do that. And you can see I get access to all the chat messages, which is great. Just as well, I can actually, let me go grab my email address that's base64 encoded. And I should be able to say NATS pub, let's see, chat.general. Whatever my base64 encoded email is. And I could say, hello world, this is from the CLI. And when I do that, I can go over to my chat application and see that my chat application was indeed also updated, which is really, really cool. But I can't chat as anybody else. If I want to just throw some gobbledygook in here or try to impersonate somebody, it's going to result in a permissions violation. And that's because we have locked down all of those subjects for that particular user. So I know this was a lot to go over. Don't be afraid to kind of check out the link below and download the code and play with it yourself, because this was kind of a wild walkthrough. But hopefully this just showcases the power of how awesome the NATS Auth Callout feature is. And I hope everybody can kind of get some ideas. I'd love to hear some more in the comments of some ideas that you have. This was just a simple example of how to do OpenID Connect, but I'm sure you can connect all sorts of other NATS auth systems together. So yeah, that's about it for this video. Again, if you like this content, feel free to like and subscribe, and we'll have more videos like this coming out soon. Jump in the comments and let me know how it was. So I'll talk to you later, and I'll see you on the next one.